Let's graph solution sets of inequalities. So a solution set is going to sometimes, depending on how it's written, going to have these squiggle brackets. And then what they do is they tell you the variable that you're using in your solution. And this part is actually the solution or the answer to whatever problem you're looking at. So in this case, the solution is x is less than -1. So that's what we're graphing. We're going to graph x values that are less than -1. So when we're looking at a number line, I don't know how your teachers do it, but generally what you need to show is that -1 is on this number line. And I want numbers that are less than -1. So I like to always include 0 so you know which way you're going. Less than or greater than, if they're not equal to, they are open circles, which means -1 is not included. And then if it's less than, we're going to graph to the left. Those numbers are less than -1, -2, -3, so on and so forth. We also have to write it in interval notation. So if you're going to the left, it's going on forever and ever, hence the arrow. So that's going to -infinity, negative over and over. So as an interval, we would write our solution as -infinity, oh, that's an 8, -infinity to -1. That would be our interval. So we're using parentheses because of the open circle. And there you go. So that's one example. Second problem. So our solution, now that we can identify it, says -11 is less than or equal to x. I would always suggest rewriting this so the variable's on the left side. Makes it a lot easier to understand what's happening. So if -11 is less than or equal to x, then x is greater than or equal to -11. I'll use a color to kind of help. The closed part of the inequality is towards the -11. So if you're flipping it, that closed part has to stay there. So to graph, if the x is on the left side, that's the key. X is on the left, it tells you, the inequality kind of tells you which direction to go on. So we're going to put -11 on the number line. This inequality has an equal to sign, so we are going to actually close that circle, which means -11 is part of our answers. If x is on the left and the inequality is pointing to the right, it means our graph is going to go to the right. So that's going to help out a ton as long as you're able to rewrite that. So that would be your graph. As an interval, this now starts at -11 because that's on the left side, and it's going in the positive direction. So 0 would be larger, and then it keeps going to positive infinity. So our interval would be written like this. Infinity will always get parentheses, and because this is a closed circle, we're going to have a bracket on that number. So infinity will always have parentheses. Your number will either get a bracket if it's a closed circle, or if it's an open circle, it's going to be given a parentheses. So let's do one more problem that looks a little more complicated. So our solution here now has two boundary values. It says -7 is less than x, which is less than 6. I think this is actually the easiest type of problem. So because it gives you two values, you do have to plot both of these. So -7 and +6 have to be on your number line. Well, x is quite literally in between both of those, which means your graph is quite literally going to be in between both of those. That would be your graph. Because you're using the less than inequality, these number values are going to have open circles. And if they're open circles, your interval is going to be using parentheses for both of those numbers. So you have your graph, you have your inequality, and as an interval, the number on the left is -7, the number on the right is 6. It is not going beyond that, and those both get parentheses. So that's how you'd graph solutions of all different types of inequalities.